What about this problem? First order differential equation, nonlinear differential equation, okay? But it is autonomous, right? And once you have like autonomous, as I said, like solving problem is not that important, okay? Like, you know, you can do that, okay? But like, I don't want to do, okay? But like a study about the equation is much better, right? So that's why we're going to start from finding equilibrium solution, because we have to do the like phase line portrait, right? So how can you do it? Equilibrium solution for autonomous is dy over dt equal to 0. Then what is my dy over dt? Y squared times 4 minus y squared equals 0, okay? For my convenience, let me do the factoring a little bit more. So therefore, my critical points are 0, 2, and -2. Is that okay? Once you find this one, we have to move to the phase line, okay? Here we go. It's really easy, right? Same thing with the number line. I mean, sign charts in Calculus 1. That's it. For this case, we have like 4 sections, right? So let me check the sign of dy dt for each section. First of all, let's start from here. What about dy dt? Less than -2. As we did before, we're going to try to plug in any value which is less than -2, which is in that section, right? Into the like your dy dt, okay? And oh, actually that is exactly this, okay? And when I plug in -3, look at the first term. It is y squared. So it is always positive. So you don't have to worry about negative case, okay? So forget about it. It's always positive. And 2 minus -3, it is positive. And 2 minus 3, it's only one negative. So we can say it's negative, which means going down direction. Between -2 to 0, let's say -1, y squared is always positive. And 2 minus -1 is 3, which is positive. And 2 minus 1 is also positive. So all of them are positive. We can say positive, going up. Okay. What happened between 0 to 2? Maybe 1. Y squared positive. 2 minus 1 positive. 2 plus 1 positive. Good. So we can say positive, going up as well. Okay. And what about bigger than 2? Maybe 100. Y squared positive. 2 minus 100 is only one negative, and 2 plus 100 is positive as well. Okay. So we can say it is going down. Does it make sense? Well, in this problem, there is one different thing, right? Look at 0, going up and up, which is semi-stable, okay? So let me conclude here, okay? So therefore, I can say the first one, -2, is unstable. And let's talk about 2 first, okay? It is stable. And 0 is the case semi-stable. Is that okay? Then you know, just guys, just calm down, okay? Don't rush, but like do the like, you know, step by step, okay? So on your phase line, and we're going to talk about like, you know, the number when your y0, which is initial value, is less than -2. Oh, it's going down direction, which means it really, your solution y goes to minus infinite as t goes to infinite. Does it make sense? And what happened at -2? It is equilibrium, okay? So which means like we have to talk about the first part, which is less than -2 first, so separate, okay? So here we go. If my y0 less than -2, then I can say limit t goes to infinite, my solution curve goes to minus infinite. That's it. And what about the case your y is equal to exactly -2? It is equilibrium, which means your solution is also stay in the equilibrium solution, okay? So like it will be -2, okay? And bigger than, oh, it is different story. So you have to separate that as well, okay? If my y0 is equal to exactly -2, then my solution curve is stay as the horizontal line. Then now let's move to like bigger than -2. Any number between -2 and 0, it is tempting to going up, and stable line, which is 0. It is like, you know, getting like converging to the 0, right? That's it, right? At what about at 0? It is like, you know, equilibrium, which is always equals 0. So we can say my y0 is like bigger than -2 and less than or equal to, let me combine that one too, okay? Then limit t goes to infinite, yt will be 0. What is next one? We did like until 0, right? And whenever you have like any like initial value bigger than 0, between 0 to 2, and all those value will converge to 2 as well, right? And also like at 2, it is 2. And bigger than 2 is going down and converge to 2, right? So like we combine everything at the same time, okay? Here we go. We step space. So when my y0 is like strictly bigger than 0, we can combine everything here. Then limit t goes to infinite yt is going to 2, which is the stable equilibrium solution, okay? And if you don't trust me, just look at the graph that I gave you below this one. There we go. See? As we did the analysis, okay, going down forever, going to minus infinity, right? And then going up. And below 0 is stable, but above 0 is unstable. That is the meaning of semi-stable, right? For your record, let me write it. Okay, and this is unstable, right? Look at that. Any value bigger than 0 is like, curve, like getting close to 2, right? Which is stable equilibrium solution, right? That's it.